Hi everyone, my name is Philip, and today I would like to give you a talk about how change detection works in Angular app today. And I think the best way to understand it is to understand the high architecture of Angular. How does it work behind the scene when our JS bundle is executed in the browser? So let's dive in. Firstly, when our JS bundle is executed in the browser, Angular app creates the incremental tree. But what is the incremental tree? I think for our purpose is enough to understand that incremental tree is a usual tree. In the next videos I will give you more details about what is incremental tree, but for now it is enough as it is a usual tree. A usual tree is the suspicious of the graph, and the graph is the data structure that consists of the edges and vertices. On the screen you can see the example of the tree, and here it is the vertex, and this one is the edge that connect one vertex with another one. And what is the data structure? The data structure is the data organization in computer memory. So if someone asks you about what data structure did you use, it means how did you save your data in the computer memory? And a lot of great developers and programmers spend a lot of time to understand what is the data structure we need to use, in our case, to use the computer memory in a very efficient way. So it is very important to understand the basic data structure and what is it. So the next one is the edge. What is the edge? Edge is an abstraction of something with which you can connect one thing with another, or simply it is a connection. And the word abstraction I understand as the parameter in the math. So you can replace this word with another one which suits for our requirements, and in this context the requirement is that it should have the ability to connect one thing with another one. And what is the vertex? Vertex is an abstraction that can be connected with different abstractions. So in this example on the left you can see that we connected three numbers. We can connect strings, objects, and so on. But if I say that we can't connect numbers with anyone, it means we can't create the tree that consists of the numbers. And of course, tree can consist one vertex, but it doesn't mean if I have one number, it means I can say that I have a tree, because number in our context is not a vertex. And I also would like to give you the definition, or a more accurate definition, what is undirected tree is, because it uses in the Angular app. Undirected tree should have the following properties. It should be a cycle. It means it should have any loops. It means that edge have the same start endpoint and end endpoint. What is start endpoint and end endpoint? It's simple nodes that edges connects. So in this example, this can be start endpoint, and this can be end endpoint, or this endpoint or start endpoint, or this start endpoint or end endpoint. And it is not the same, and it is not the loop. But if I will create the following edge, it will be the loop, because the start and end point is the same node. And what is the circuit? The circuit is the situation when we can visit the same node more than one times using the different edges. Why the different edges? Because here we can say that we have a circuit. If we will go like this, we will go like this and go to the opposite side, and we will visit the same node twice. But we used the same edges, and it isn't the circuit. So how to create a circuit in this example? In this example, we can create the circuit by creating the following edge. And if we will go like this, like this, like this, like this, we will visit the same node twice using a different edge, and it will mean that we have a circuit. Okay, and the following property is the connected. It means that if I will select any random node in the graph, I will have ability to reach any another node in the graph. So for example, if I will select this node, I can reach another node like these, and so on. And the third property is very useful when you solve some problems, for example, in the LeetCode. If you have n nodes, it means that you have n-1 edges. In this example, we have 7 edges, not edges, nodes, and it means we have 6 edges. Okay, we understood what is the incremental tree, but what is the vertex in Angular app? It is a view, and a view is a usual JavaScript object, or it is an Angular component. As you remember, Angular component is a class, and Angular uses the usual approach how to create an object. It uses the constructor, and it is the reason why we have the following rule. Don't put a lot of logic or complex logic in the constructor, because if we will put a lot of logic in the constructor, it means we will have a very big time to build the incremental tree. And incremental tree is in the synchronized state with the DOM elements. It means when we create the incremental tree, we create and the DOM elements. And because of that, we have a very good time to create the incremental tree. The rendering time for the user will be very, very quick. So don't put a lot of logic in the constructor. And also here we have a rule that don't try to change DOM elements not using the Angular features or possibilities. Use only Angular features for that. If you will create straightforward in the DOM element something, it will be the source of the bugs, because the incremental tree will be in not synchronized state with the DOM elements. So we passed the creation of incremental tree, and now we have the second state. It is the change detection. And change detection is a usual method of JavaScript objects or a view. And view, it is the nodes of the incremental tree. And the change detection has the following algorithm. It consists of the 14 steps, and you don't need to remember all of them. You can read them by yourself. I will put the articles where I wrote them, and you can learn by yourself and understood it. If you will have some problems or you will have some questions, please write in the comments and I will try to help you. But here I will highlight some very important steps in this algorithm. And also I would like to notice that don't remember all the steps. Please understand the concept, the ideas, because Angular change detection algorithms is constantly changes to improve the performance. But the main idea is keeping always. So firstly, checks view state, checks enabled, and flag is dirty. And if it is false, the CD or change detection does not process these objects and its descendants. So what does it mean? It means, for example, if checks enabled is false here, these nodes won't be proceed with change detection. And checks enabled means, does this component of view or objects attach or detach from the tree? We can use it manually using the change detection reference, but we will see it on the next video. And the isDirty flag shows the state of the component. Do we have something in the component that was changed and the UI should be rendered? And after this situation, isDirty will be the true, and the change detection will know that we need to execute the change detection in this component. Sixth step is calls on changes lifecycle hook on a child component if bindings changed. You need to understand that if on change lifecycle hook was called, it doesn't mean that we calls the change detection. It is the separate. It can be that on change lifecycle hook was called, but change detection wasn't invoked in this component. A lot of people can't distinguish it, so please distinguish. And the 10th step updates DOM interpolations for the current view if properties are changed in the current view. So here I would like to notice and to highlight some things. How Angular updates the DOM. The Angular stores all references to the DOM element that can be changed in the arrays, and before the updating in the DOM, we comparing the previous value with the current value using the references. So don't mutate your objects, create the new ones to create the new references, and you won't have any bugs. And if the current and previous value is the same, we will skip the element. We won't update it because it will take a lot of time, a lot of resources from the computer to render it. So we only render the elements that should be changed because the previous value and the current value is not the same. And the 14th step is very important because, as you know, in Angular we have the two strategies, on push and the default. And the 14th step is the main difference between them. When the default change detection uses the same algorithm, but it doesn't change the isDirty flag back to the false, and because of that, if someone should be re-rendered, we will re-render the whole tree, and it has a very bad impact on our performance. So please don't use the default only on push. And on push, disable isDirty to the false, so it back to the false. So it executes the following algorithm, and at the end it back isDirty to false. And because of that, if, for example, only this component should be updated, we will update only this component and its children if it needs, but not this part. Not this part because isDirty is false. But on the default, as after change detection proceed all the trees, it doesn't disable checks, it doesn't back isDirty flag to false. If this one component should be re-rendered, the whole tree will be proceed with change detection, and it is very bad for the performance. And I understand it is very difficult to understand in the mind because it is very high abstraction how it works. I try to create a simple example how view and how change detection can be implemented. Of course, in Angular source, it is implemented in very difficult way using the very difficult and very optimized algorithm, but we don't need to know this to optimize our Angular apps and to understand how change detection works, because it is very small details and we need only understand the concepts. And here you see that we checked, does this component detached or attached to the tree, does something is changed inside of the component, and we need to re-render in the component, and we update input and change detection for children. We go through the mdet views. The mdet views, it is the components that was created using the template, and then call lifecycle hooks and go through the children's and call the change detection. So it is the change detection, and it call each detection one step by step in incremental tree, like a recursion function call. And I think the last thing that I would like to highlight, it is how we can trigger the change detection. A lot of people can't distinguish that we need to trigger the change detection and change the state of the component. Many people think if we will change the input, we will trigger the change detection, but it is not true. Thanks to the Zone.js, it happens automatically. And to see on what operations we trigger change detection, you should to go to the Zone.js library and to see the list of these operations, but I remember only the important ones. This is the micro and micro tasks, this is asynchronous operations, and it is the UI events, it is browser events, and it is some user events like click and so on. And only after this, we triggers the root change detection and it checks the flags as we saw in the following algorithm that consists of 14 steps. But input only change the isDirty flag. And we can all these do manually using the change detection references. And we will see it in the next video how we can combine this theory knowledge with the practice, how we can do this manually, and how we can optimize our Angular application. Also, I think it is good to mention, and I will mention also in the next video, that in the development mode we have a 2 cycle to detect some problems in our logic. Like change detection, after one cycle, it involves the second cycle to check, did we change something after one cycle? And if it is, we have the problem because our tree, our logic, our state is not in synchronous state with DOM elements and the user C and alt values. We will also mention it in the next video, but on this it is the end, and I hope you like it. I helped you to understand how change detection works, what is it, and if you like my contents and videos, please subscribe and like this video. It motivates me very a lot. And thank you for your time, thank you for your attention. See you in the next video. Goodbye, have a good day.